In this video, we're going to look and see how we can add a new instruction to our instruction set. Now, we wouldn't normally have to do this because the instruction set is pretty full and we've got pretty much everything in it that we want. But by going through this process, it will help you understand more about how the CPU works. And also, if you decide you want to add in new instructions and you think of other instructions that you think will be more useful, it will allow you to go ahead and do that. So we're going to start off by looking at the instruction set. So if you come into the instruction set.md, now the idea I had for this video is that what we could do is we could change or add on to the move instruction. So at the moment, the move instruction allows us to move information from one register to another register, or from one memory location to another memory location. So the move is only register to register and memory to memory. So the move command cannot be used in order to move information from the register to the memory or the memory back to the register. And in fact, we've already got commands in here that do that for us. So the load command here is used to take information from the memory back into the register. And the store command is used to take information from the register to the memory. Now, these are commands that we've generated over the last few courses. And they're, if you like, the history of this design. But it might have been better to just generate one command. So one command like the move command, which we could use to move information from register to register, memory to memory, memory to register, and register to memory. And what we're going to do now is we will update the existing move command and we'll put in the two other options. That is, we want to be able to move from memory to register and register to memory. So let's crack on and I'll show you how we're going to do this. So if we look at the existing load and store instructions, you'll see that we have this one here which says store rx, address. So an example of this would be store R0, 10. So we're storing the contents of register R0 into memory location 10. Now if you have a look up at this one here, we have got the load address, Rx, and it's going to load the contents of memory location 10 into register R1. So in these two existing load and store instructions, they do exactly what we want the new addressing modes for move to do. So it means that the microcode or the micro instructions for this store instruction and this load instruction are exactly the microcode that we require. So we could in effect just copy the microcode from these and put it into the microcode for our new move instructions. So what we're going to do next is show you exactly where we're going to get this microcode and how we're going to change everything so we can make it all work. Now let's have a look at the existing move instructions. So you can see here we've got an address location 1C00 and 1D00. So these are two of our existing addressing modes. So we've got another two available to us that we can use. So the first addressing mode is moving from one address location to another address location. The next one is moving from one register to another register. So you can see here we've got 1C and 1D. So we've got available to us 1E and 1F. And then the next one we jump on to is 0 cross 2000. So we can put a couple of spaces in here and we can copy over these lines. And then we can update them. So this is going to be 1E and this one will be 1F. Now let's make the 1E one a movement from a register location to an address. So we're going to move now from RX to some address, so we can put ADDR. And this one here, we're going to move from a register location ADDR into some memory, we're going to move from a memory location into a register. So we can put an example of it here. So we could be moving from contents of register R1 into an address, say 200. Or we could be moving from an address 200 into a register R0. So we're going to move the contents of register R0 to memory location 200, or move the contents of memory location 200 to the register. In this case here, it's register R1. We'll make it R0. Okay, so these are our two new addressing modes. So let's go ahead and we'll see how we're actually going to change the assembler in order to give us these addressing modes. So we can run up the assembler, which is in the tools, and there it's assembler.py. So we have the assembler here, and this is the top of the assembler program. Now if we run down to this section here, which contains all of our instructions. Now we can come down to the move instruction, and you can see here that we have only the two addressing modes. So what we can do is we can add in the other two addressing modes. So what are the other two addressing modes? Well, it's going to be a register to an address. So it's going to be register underscore address. So that's the first one. And the next one is going to be from an address to a register. So these are our two extra addressing modes, and that's all we have to do in here. So we can save this file, save. Now if you were adding in an entirely new command, you would come down to the bottom here and you would add in a whole new line, and then you would adjust and pick out the very next available opcode location. So in this case it would be 110001, and then you would choose the different addressing modes that you want. And you can see here in this example we've only chosen 3 addressing modes. You could choose 1 or 2 or 3 or 4. So now that we have our assembler updated, what we can do is go in and actually generate a little piece of code. So we can get into ASM and we can create a new file, and we could call it move underscore test.asm, and we can put in code, 0 cross 8000, and we can try out our new command. So we're going to have a move, and let's say we're moving from a register R0 to an address location. So let's pick out an address 0 cross B triple 000. Okay, and then we can try the other addressing mode, which is move move 0 cross B triple 0, comma, and we'll put in R3, and then we'll put in end, and we should be able to run this. Terminal, run task, and we've got assemble file. And you can see here it's got an error. So we'll go in and we'll have a little look and see exactly where that error has occurred. So actually the error is quite simple. It's got to be 0 cross B 000. And we can run that again. So we can see the assembly has been successful. So we can actually go in now and we can have a look at the machine code. So we're going to go to the MC folder, and it's a file called move test. So move test, and there you can see we've got the different commands. So the command that we're going to use was 1E, and then we're going to have the address location, which in this case is 0 cross B triple 0. And the assembler has done this for us. It's generated this position here and put it in. Okay. Now the other one was the 1F, and we're going to be using register R3. And again, we're going to be putting the contents into this register. The contents are going to come from register B triple 0 back into this register R3. So it's generated the commands correctly, and we've got the end command. Now so far all we have done is update our assembler with the new addressing modes for our move instruction, and also updated this instruction set file. But we haven't built any of the micro instructions in order to do these moves. So what we can do is we can get into microcode, and all of our micro instructions are held within this file here, which is called microcode.json. So if we open this up and we head up to the top, you can see here we've got the data command, we've got a compare A, the load, the store. So we've got all of our commands here. So let's just pick one out as an example. So if we pick out, we'll leave the move for the moment because we're going to be using that. So here's the add command. Now the add command's got 4 addressing modes. So the first one here, that's addressing mode 0, and we've got all of the micro instructions. And we've got addressing mode 1 with the micro instructions, and 2 and 3. So if we were to add in a whole new command, what we would do on instruction, what we would do is we would come to the bottom and we would have a whole new instruction added in at the bottom here. But it's fraught with danger going in and updating this file by hand. If you do anything just wrong, anything not in the right position, then we'll get an error and nothing will work. So I've generated a command line interpreter in order to adjust this file. So if you like, this file is like the original Excel spreadsheet that we generated in order to do this, but all of the Excel spreadsheets have gone and everything has gone on to the command line interpreter and the microcode JSON file via our Visual Studio code editor. So let's move up and we'll have a look at this move command that exists. It's the load, the store, the jump to subroutine, push, pop, and there's the move. So the move command's got the addressing mode 0 and addressing mode 1. But you can see addressing mode 2 and addressing mode 3 have just got the stop command. That is, they are empty. So we need to generate the new microcode for these two instructions. Now, as I said, the store command and the load command have already got this microcode generated for us, because in effect they do exactly the same thing. They're just called different instructions. So potentially we could just copy the values from our store and our load, and we can place them in here, and that should be us ready to go. Now if we open up the instruction set and we're looking for the store instruction. Now the store instruction's got 4 addressing modes. The one we're interested in is the very first one, which is register to address. So we're interested in the store and the addressing mode 0. So we can go in and we can open up the command line interpreter for the microcode. So it's edit microcode, and we've got the command line interpreter here. So we can go in and we're wanting to have a look at that actual instruction. So if we type in help, it's got all of the available commands for us, and we're looking to view instruction mode. So we can put in view store and it's instruction mode 0. So these are the instructions, or the microcode for our store instruction. Now we can actually have a look and see exactly what these do. So if we head in and we have a look at micro steps, and it's the store instruction and it's addressing mode 0, and it tells us exactly what that instruction does. So I've got the actual machine code for our move instructions. So the one we're interested in is the 1E00 and then the B000. So the 1E is the opcode for our move instruction, which moves from contents of a register to a memory location. And the very next position here tells us where that memory location is. So remember that this here is sitting in an address in our ROM, say it's 0x8000, and then the next one here is sitting in an address, and it would be 0x8001. So these 2 points here are memory locations. Now within the memory location we've got the actual opcode, and within this memory location we've got this B000. But the B000 refers to another memory location. It tells us where we want to store the contents of register R0. So it means that whenever we come down to this set of instructions, if you'll note, we've got instruction address register enabled. Now the way our fetch execute cycle works, if you remember, is that once it's fetched them, it adds one on to the instruction address register. So the instruction address register doesn't contain the address of the instruction you're running now. It points to the next address. So it's actually pointing to this address here. I don't mean it's pointing to B000, it's pointing to the 0x8001. So if we're pointing to address 0x8001, what we can do is we can set the memory address register. So now the memory address register is pointing to address 8001, and we can then set the value in the accumulator. We can then do control enabled. So when we do control enabled, we're taking the value of the contents of register 8001, which is B000. We're taking it out and we're putting it into the cash register. But we've still not got access to the actual position here within the memory. We've only got access to the 0x8001. So we're going to enable the value B000 onto the bus, and we're going to set the memory address register again. So we're actually going to have access to now the memory location B000. So now we've got access to the memory location. What we can do is we can enable the reg A onto the bus. So reg A would be, for example, register R0. So this is where we're moving information. We're moving information from the register into a memory location. Now we're already pointing to the memory location 0x B000. So what we can do is we can do the control set, and what that does is it takes the contents of register R0 and it puts it into this memory location that we're now pointing to, which is 0x B000. We now do the accumulator enabled. Now what we've got up here as well, as you notice, we've got this bus 1, because when we're finished this command here, an instruction, we don't want to be sitting in this position, because this position here contains a memory location. It doesn't contain the next instruction. The next instruction is the next one along. So we're going to have to add 1 on to our instruction address register. So that's why we've got this bus 1 and why we've got the accumulator set, because it's now going to take in the accumulator, and the accumulator will be pointing to this next address here. So what we can do then is enable the accumulator onto the bus, because it's pointing to this address, and we can save it in the instruction address register. So now the instruction address register is pointing to the next instruction, and then we can stop. So you can see it's actually quite a difficult thing to describe in words, and it's much better for you to run through the simulations and actually run through one clock pulse at a time and see it actually working. So we can take these micro instructions and we can place them into our new move addressing mode, and they should work. So let's go ahead and we'll do that now. So I have the Microsoft JSON file open. Now we could go into the file and edit it by hand. So I could go to the store instruction addressing mode 0, and I could copy the micro instructions and then just paste them in at this point here, which is addressing mode 2 of the move command. And that's what I would normally do. It's relatively easy and straightforward. But I also have the command line interpreter which can do this for us. So for example, if we look at this here, it says edit control instruction mode index signals. Well, there's an example here, so we can edit the control of the add instruction, and it's addressing mode 0 and instruction 0, and we can actually just type in what we want to do. So we can use this same setup here. So I can type in edit control, and the opcode is the move, the addressing mode is 2, and we're interested in the very first micro instruction, which is 0. And we're going to change it, we're going to generate it, so it'll be instruction address register underscore enabled bus 1, memory address register underscore set, and accumulator underscore set. Now when I press return on this, you can see it's updated it, and it's actually generated the full microcode just from these here. So I can save this, and when I save it, it should appear, and there you see it's appeared in here. So that's the very first part of our micro instruction. Now I can go ahead and I can do the same for the other. So edit control, and it's going to be edit control, and we're going to have the move command, and it's the second addressing mode, and it's in the actual instruction, micro instruction is 1, and we're going to have the control underscore enabled and the cache underscore set. Right, okay, edit updated move, step 2. So I can save this, and you can see it's appeared here. So I'll go ahead and I'll generate the rest of this. So I've gone ahead and I've updated the move command. So we've got all of the micro instructions for addressing mode 2 and the micro instructions for addressing mode 3. So what we need to go in and have a look at this to check and make sure everything is okay. So we can go in, terminal, run task, and we can edit microcode. And again, this will run up the command line interpreter, and it will allow us to go in and actually check and see that everything's okay. So we can do edit, or we actually want to go in and look at the micro steps, and it's going to be the move instruction, and it's going to be addressing mode 2, and you can see we've got the micro instruction set up here, and we've also got the micro steps for the move command, and it's going to be addressing mode 3, and those are all entered as well. So now that we've done that, we can go ahead and we can output the actual files. So again, we've got the options here if we put in the help, and we've got the options to export all of the tables. So we can use the save command here. So if we do save, it will go ahead and it will save 2 files. It will save the microcode.json. It will also save the other 2 files that we require to put into our microcoded control unit. So that is the microcoded ROM and also the lookup table. So you can see those 2 files that are going to be sitting here. So we've got a file here that's called microcode underscore lookup, and we've also got the other one which is going to be the microcode.uc. So these are the 2 files that we're going to enter into our microcoded control unit. Now I used to generate these via the Excel spreadsheet, but as I said, these are gone, and this tool will automatically generate these for us. And in fact, whenever we quit, it would ask us whether we want to save if we hadn't already saved, and then it would save these for us. So let's go ahead and we'll enter these files into our CPU. So we have our CPU here, and if we come down into the control section, we've got a microcoded ROM. So we've got our lookup table, so we can go edit contents and we can open. Now the file is going to be inside the microcode folder, and it's got the LUT, so that's the lookup table. So we press OK on that, and it will have added in the other 2 move instructions, or the pointers to those instructions, and we can go edit open, and again we're going to go into our microcode, and we've got our microcode underscore UC file. So if we open this, it's opened, it's updated all of the microcode ROM instructions. So that's us all ready to go. We can go File, Save. We'll go back to our top level. Now we're ready to go in and actually test it out in the machine and see that it does actually work. So I've generated a tiny little bit of code here. So we're going to put the number 1 into register R0. We're going to move the number 1 from register R0 into this memory location 0 cross B 0005. And then we're going to go to memory location 0 cross B 000, and we're going to take the number and move it into register R5. So when we finish, we should have 1 in register R0, 1 in this memory location, and 1 in register R5. So we can go in and we'll go terminal, run task, and we can assemble the file. And that's assembly successful. And now we can get in and we can load the program into our machine. So edit contents, open, and we'll find our program, which is going to be in the MC folder, and it's going to be move test.mc, open, and we've got our program loaded up here. So we close the window, design, user panel, simulate, tick enabled. So you can see here that if we stop this, we've got register R0's got the number 1. Now it should have placed the number 1 into the memory location, and then from the memory location it's taken it back and put it into register R5. So let's have a look at the actual memory location, which is going to be 0 cross B 000, which should be 3000 here. So that's 3000. So you can see at 3000 we've got the number 1. So it's done exactly what we want to. So now we've got an extra couple of instructions that can move content from a register to a memory location and a memory location back to the register. So you can see that it's quite an involved process in order to describe it to you all in words and show you it all happening. But once you went through and did it 2 or 3 times, it's relatively straightforward, and if I was doing this without having to describe it, this whole process would have taken me about 10 minutes. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.